Okay, happy to another integral. This one was sent to me by Sid. We've got the integral from 0 to 1 of x to the s minus 1 times cosine natural log x dx, and we have this condition on this that s is going to be greater than 0. So the first thing I noticed about this one is just the fact that we've got natural log inside cosine. And what I was thinking is maybe we can clean this up with a substitution. What I'm going to do is we could do t equal to ln x. When I did it this way the first time, I realized that's going to end up, we're going to end up with our bounds going to minus infinity. If I make our substitution for t minus ln x, that way our bounds are going to be going to infinity instead of minus infinity. So I think this could be a little bit nicer. What I can do is rearrange this and we can solve for x. So we're going to have natural log x is equal to minus t. Then with log properties solve for x, we have x is going to be just e minus t. I'll take a derivative on this to get our dx value. Dx is going to be just e minus t. A minus is going to come out, dt. So I'll go ahead and do the substitution. First I need to plug 1 in someplace. Plug in 1 right there. Natural log of 1 is going to be 0, so our upper bound is just going to be 0. Plug in 0, we have minus infinity, but the minus is going to turn that into positive infinity. Now our x is going to be e to the minus t. Let me see if I can, how can I rearrange this? If we have this e minus t to the s minus 1, I guess I think I'll just leave this for now and we'll rearrange this later. Then this is going to become cosine minus t, but cosine's an even function, so the minus isn't going to matter here. This is just going to become a plus. That'll go away. And then our dx is all this stuff, minus e minus t dt. Now from here, let's take this minus sign, bring it up front, and use this to swap the bounds. So now we'll be going from 0 to infinity. And then I can rewrite this, and what we can do is, here we've got the same base, e and e, and they both have minus t in common. So like think of this like minus t with like a plus 1, and here's the minus 1. So when we put this together, this is just going to become e minus st times cosine t dt. And then what do we notice right here? This is actually perfectly set up as a Laplace transform, where like this is our f of t in the Laplace transform formula. And so this whole thing here is going to be just the Laplace transform of cosine of t. And for that, we can just use a formula. We usually have this formula, Laplace transform of cosine at. That's going to be the same thing as s squared plus a squared with an s in the numerator. But in our case right here, like the coefficient on the cosine is just 1. So that's going to be our a value over here. So using this formula for our final solution, we just get s over s squared plus 1. Okay, so that one went pretty fast. Thanks again to Sid for sending me the problem. Thanks everyone today for watching. Have a good day.